Hi, today we're going to be talking about solving equations. So to start us off, this is just kind of an intro video and some basics. So first we want to talk about what is an equation. Okay, an equation is something in math that has an equal sign and the two sides have equal value or have the same value. So let's look at a couple things that make and identify if they are an equation or not an equation. So if I have something like 3 plus 2 equals 4 plus 1, while I have to do a little bit of simplifying on each side, it's easy to see 3 plus 2 is equal to 5, and 4 plus 1 is equal to 5. And we have an equal sign in between, so then we can say, yes, this is an equation. I'd like you to notice that an equation is actually made up of two expressions. Okay, so we have an expression on this side of the equation and an expression on this other side of the equation. Okay, and then if I have something just like that says 3 plus 2 equals 5 plus 2, if I simplify these two expressions, we know 3 plus 2 is 5, and we know 5 plus 2 is 7. And so we have the statement that says 5 equals 7. This is not a true statement. So then this actually is not an equation. For something to be an equation, the two expressions on either side have to have the same value. They have to simplify to the same value. So if I tell you something is an equation, you know those two sides of the equation are equivalent to each other. They have the same value. Okay? And then let's say I just have something like 3 plus 2. While I can simplify this down to 5, this is not an equation. This is actually an expression. Okay, an expression is just an idea in math, talking about, think of it like a sentence fragment, versus an equation is telling you these two expressions have the same value. This is not comparing to anything at all, just talking about itself, so it is an expression. Okay, so when we talk about solving an equation, sorry. When we talk about solving an equation, that means to find the missing numbers. And it could be one number or it could be many numbers. So number are numbers that make the equation true. Okay, so that's what we mean when we talk about solving an equation. And you guys have done equations in the past, but we're just going to do a couple to kind of make sure we're all talking about the same expectations here. So if I have something like x plus 7 equals 10, when I'm talking about solving this equation, I'm talking about finding that missing value in this equation so that I have an equation, that I have a true statement here. And so I know you guys have learned in the past, you do those opposite operations to isolate the variable. So since this says plus 7, I'm going to do that opposite and I'm going to minus 7 to both sides. And the reason you have to do things to both sides of an equation is that because these sides are equal, because they have the same value, if I take 7 away from this side, I need to take 7 away from this side so that my value of those sides stays equal. If I only change one side in an equation, then it is no longer an equation. Okay? Those are not equal sides anymore. Okay? And I'm able to find my answer. Now, a good habit when you're solving equations is then to also do a check. So when I do a check, I start by writing down my original equation, and then I'm just going to substitute in what I found for my variable to make sure it works. So then I just simplify each side independently. So 3 plus 7 I see is 10, and I still have my equal sign, and the other side doesn't have any simplifying left, and I can see I do have a true statement at the end. So x being 3 is my missing value that makes this an equation, that makes it true. So I'm just going to write some quick notes in here for what we just said, but to do a check, okay, the first thing you're going to do is write down the equation, the original equation. And the second thing you are going to do is you're going to substitute the number for the variable. And then the last thing you're going to do is you're going to simplify the expressions on both sides of the equation. Okay, and so those are your steps to check. Okay, and then when I'm solving equations, we're going to get some directions to solve equations here as well. Okay, so to solve equations, the first thing you want to do is simplify expressions on each side as generally as much as possible. So the first thing you're going to want to do is simplify your expressions on both sides of the equal sign. That means if there's distributive property, do your distributive property. If there's combining like terms, combine your like terms. So simplify on both sides of the equation. Okay, and then the second thing you're going to do, okay, is you're going to want to make sure that your variables are on one side of an equation and that you can combine those variables. Okay, you're going to combine like terms. And this is kind of actually part of your simplifying here. Make sure variables are on one side of the equation. And it doesn't matter left or right. And that's because since the two sides are equal, whether it's on the left or the right doesn't really matter. You just want them together. And then the next process you're going to do is that you're just going to try to isolate that variable by performing inverse operations. So the opposite, and that's what's going to get it to isolate. And you can see we did that here. It said +7. The opposite operation of addition is subtraction. So we do that inverse operation. So now to isolate the variable, perform inverse operations. And it's going to put some notes for some people in here. So when I say isolate, that means to get alone. And then when I say inverse, I'm meaning the opposite here. Okay, so we're going to look at a couple more complex problems than just a one step up that we did up here. I'm going to turn the page here and we're going to do just a couple equations. Okay. So let's say I have something like 3x plus 9 equals, let's say, 45. Okay, so on this, I can see right now, I just have an expression over here that really doesn't have any simplifying to do at all. Everything's combined as much as I can. So now I'm just going to go through and try to isolate my variable by performing those inverse operations. And I'm actually going to solve this equation two different ways because I know a lot of people say you have to do it one way. Well, that's not really true. Part of the reason we have so many of these discoveries in math is that when someone asks, well, can I do it this way? And a lot of times, yes, but you still got to just make sure what you're doing is mathematically sound. So one of the most common ways people go about solving this is they will first subtract 9 to both sides to try to isolate that 3x. And so 9 minus 9 here, that gives me 0, and that's why we say that cancels out. We're actually doing that operation, doing that calculation. And so now I'm left with my 3x equals, and then on this side I'll do that arithmetic as well. 45 minus 9 gives me 36. And then now that I just have this 3x, there really is an operation in between there. Whenever you have a number next to a variable, that means multiply. So I'm going to do that opposite operation. I'm going to divide. And in math, we can show division with a fraction line. So I'm going to divide both sides by 3. 3x divided by 3 just gives me 1x. So I can put my little 1 there if I want. And then I have 36 divided by 3, which gives me 12. And then whether I show 1x or I just write it as x, those mean the same thing. It's just like if I say I have a dog, it's like you all know I mean I have one dog. So on here, same thing. I have 1x means I have ax. Okay. Now I said I could solve this another way as well. So I don't have to start with subtracting 9. Because when I look here, I see, oh, everything's divisible by 3. I could actually start with the division here. And I'm going to divide both sides by 3. Now notice I'm not just dividing the 3 by 3, and I'm not just dividing with 45 by 3. I'm dividing everything on this whole side. That's why I have a much longer fraction line there, a division symbol. And so I'm basically distributing divide by 3. So 3x divided by 3 gives me that 1x. And then I have 9 divided by 3 gives me 3. And then on this side I have 45 divided by 3. And that is going to give me 3 goes into 4 once, leaves me with 15. It's going to give me 15. And so now I just have to cancel out this 3 because remember this 1, I don't really need to show it. I could just show it as an x. So to cancel out this plus 3, I do that opposite operation. So I'm going to subtract 3. And again, I got to do it to both sides so that my equation stays an equation. If I only do it to one side, I've created an inequality. So 3 minus 3 is 0. So I don't really need that anymore. And I'm now left with just my x, my 1x. And 15 minus 3 is 12. So you can see, regardless of which way I did it, I'm going to get the same answer. So when you're working in class, if you don't do it the way most people are doing it, it doesn't necessarily mean you're wrong. And that's why it is very important to do a check, especially if you and someone else are working and checking your work. If you don't do the same thing, but you end up with the same answer, you guys both most likely did something or did it mathematically correct. It just took different routes there, and that's okay. So in my check here, I'm going to start by substituting that 12 in. And now I'm just going to go through and simplify this side as much as I can. So first I say I have 3 times 12, so I'm going to make that a 36. I'm just doing my calculations. And then 36 plus 9 gives me 45, and I can see that it is equal. So I do have an equation, so that means 12 is the number I was looking for because it does make this a true equation. Okay, we're just going to do one more problem that's a little bit more complex. Okay, so let's say I have something like 7x plus 8 equals 9x minus 20. Okay, and again, I'm going to show this 2 different ways because it does not, there are many ways you can go about solving equations. There is not one way, okay? So for me, when I look at this, I immediately notice I have variables in there twice, and they're actually separated by this equal sign. So I can't just combine them straight off. They have to be on the same side of the equal sign to do that. So I'm going to decide to cancel one of them, okay? And I'm going to get rid of this 7x here. So as I know, if I subtract 7x from 7x, I'm going to get 0, and then I'm not going to have a variable on that side. And that's what I want to do. But because it's an equation, I have to do the same action to both sides so that my equation stays equal. So then 7x minus 7x gives me 0x, so I can just not worry about that. And 9x minus 7x gives me 2x. And then here I don't have any operations happening with my 8, and I don't have any operations happening with my minus 20. Okay, and so now I have my variables on one side. And now I just got to go through and isolate. And again, from here, I have a couple different choices on what to do, right? So I'm going to work on the side that has my variable and try to isolate that variable. So I'm going to add 20 to both sides. That way, I'm having less things near my variable. So I have negative 20 plus 20. Since those are opposites, I'm going to end up with a 0 there. And then I have 8 plus 20, and I see 28. And I can just bring down my 2x. And now from here, I still just need to isolate my variable. So again, when I have a number next to a variable, that means multiply. And that opposite operation of multiplication is division. So I'm going to divide both sides by 2. That way 2 divided by 2 gives me that 1x. And then 28 divided by 2 gives me 14. And again, whether I show a 1x or not doesn't matter. And it doesn't really matter what side of the equation my equal sign or my x is on either, okay, because both sides are the same value. Okay, now I also see that this stage here that there's a lot of different things people do. And a common thing I see people do from that stage, and I really want to talk about this, because I see people do this and they end up making a mistake, but they can still do it and get it correct. I see a lot of people, instead of adding 20 like I did here, they'll decide they're going to subtract 8 to both sides. Here's the thing, there's absolutely nothing wrong with doing that. 8 minus 8 gives me 0. I just can't lose that 0 because it's that whole other side of my equal sign. It can't disappear. I still have my 2x, and then I have negative 28 minus 8, and that's going to give me a negative 28. So there's nothing wrong with doing that. And now I just got to isolate my variable. From here, I often see a lot of people decide that they're going to divide by 2. And again, I just got to make sure I divide both sides of the equation by 2. And so now I'm going to end up with 0 equals 2x divided by 2 gives me just a 1x, and a negative 28 divided by 2 giving me a negative 14. Now you can see here, I'm just going to rewrite it right here. You can see here that I actually have not finished isolating my variable, but it's a lot simpler of an equation. So now I'm just going to isolate my variable. I'm going to add 14 to both sides. And I end up just like I did in my other method, having 14 equals x. Okay, and I'm showing this method because I often see students take this and subtract that 8 to both sides. But a lot of times people then shift their equation sign. So there again, there is nothing wrong with subtracting 8 to both sides, but you can see it is a little bit of a longer route, but that's fine. Okay, I also know a lot of times in the past, teachers have always taught you to move your variable to the left. But since equations are equal on both sides, it really doesn't matter if your variables are on both sides. That's why I subtracted 7x. Originally, because by subtracting 7x, I ended up with a positive number for my variable. If you're someone who just always likes to move your variable to the left, there is absolutely nothing wrong with that. If I move my 9x to the other side and cancel this out over here, 9x minus 9x gives me 0x, then I'm going to have an equation now that equals 7x minus 2x, or negative 2x, and my negative 20. Okay, so very similar to over here. Okay, just a slightly different, and I have to now think about that negative in front of variables. Okay, so I'm going to go through and isolate my variable. I'm going to subtract that 8 to both sides. That cancels because 8 minus 8 is 0. I'm left with negative 2x equals negative 20 minus 8. This is negative 28. And now I just need to make sure I finish isolating that variable. And again, when I have a number next to a variable, that means multiply. So my opposite operation is division. So I'm going to divide both sides by negative 2. Negative 2x divided by negative 2 is that 1x again. And then negative 28 divided by negative 2 is that positive 14. And again, whether I show that 1 in front of my x or not does not really matter. And I get my answer. So here was 3 different methods to solve the same equation. And this is why it is extremely important for you to show your work in math class, because there is so many different routes to getting to where you need to be and to find a solution that we need to see that work. As you can see, 3 different spots, and there's lots of different places to make a mistake. So again, anytime I'm giving you work for solving equations, I am going to expect you to upload your work. So please be aware of that. And one other thing I want to go over is my line here that I'm using for division. I'm using a fraction line. And this is just a little factoid for you. Okay, this is a division symbol. Okay, it actually comes out of the fact that it looks like a fraction. Okay, this little dot at the top, it represents your numerator. And the little dot on the bottom represents your denominator. Okay, and so your division symbol is actually just a shortcut to writing a fraction. So instead of writing 2 divided by 3, I can write that as 2 over 3. These are the same thing, and that's what these dots are telling you, is that this really is a fraction. Okay, so that's why I'm using my fraction line as my division symbol there. Okay, and that is it for our video today on some basics for solving equations. Bye, guys.